All right, guys. So as I was saying, if we are going to say a side is opposite or adjacent, remember now, we are not referring to the longest side, which is the hypotenuse, as being opposite or adjacent. We don't say that the hypotenuse is opposite or adjacent. The only other sides can be opposite or adjacent is the other two sides that are at right angle to each other. And if we are going to refer to a side as being opposite, we have to relate it to the angle which it is opposite to. We are going to relate to a side as being adjacent. We have to also relate it to the angle that it is adjacent to. And as I mentioned before, the word adjacent means alongside. So if we look at the two sides that are right angle to each other, we can say that the side C is opposite to the angle C, but the side C is alongside the angle A, so that would make it adjacent to the angle A. So this side C, or if you may, you can say the side AB is opposite to the angle C, and the side AB is adjacent to the angle A. All right, now if we are referring to the side A, we can say the side A is opposite to the angle A, or if we want to say the side BC is opposite to the angle A, but the side BC is adjacent to the angle C. All right, so that is something that you have to be familiar with and make sure that you have a good grasp of that, because a lot of what we'll be doing in with triangles going to lead into trigonometry. Matter of fact, once you start studying triangles, we really start studying trigonometry, all right? Because trigonometry is a word that relates to triangle. All right, so any question about what I've just explained about opposite and adjacent?
Yes, sir. Can you say why we can't say that the hypotenuse is opposite to another angle?
Right, so we reserve the hypotenuse to be the hypotenuse. So it is the longest side, so we just simply refer to it as hypotenuse. So it already has its name as hypotenuse. So because of that, and since the only angle that the hypotenuse is opposite to is a 90-degree angle. So because of that, we kind of just have that special name for that, and then now refer to the other two sides as either opposite or adjacent in relation to the other non-right angles that we are dealing with.
Okay.
Right, so that is the standard of how we actually refer to these sides, all right? All right, so with that in mind, we can move on to the next part of dealing with right angle triangles. Now, one of the things about triangles is that there are times when we may be asked to either find the length of one of the sides or the angle. Now, every triangles we say have 6 elements to it. And the 6 elements of a triangle would be 3 sides and 3 angles. So at some point, we may want to measure or calculate an angle. At some point, we may want to measure or calculate a side. And what we're going to be looking at now is a theorem known as Pythagoras Theorem, which relates the sides of right angle triangle. And a theorem is really an accepted principle or an accepted law that somewhat is considered to be a fact. All right, so once we talk about a theorem, we are saying that this is always a fact. Although the word theorem comes from the word theory. And theory suggests that what might be facts today might not be fact tomorrow, right? So it means that theories can change. But as it is in relation to math, a lot of these laws and theories are really been around. They have been around for as long as it was invented. So some of these are not going anywhere in terms of changing. So what these theories are, they will remain factual once you're doing mathematics. All right, so with that said, what is the theory behind Pythagoras' theorem? Now, Pythagoras, no, I'm just giving you a background. So Pythagoras is the name of a person. And his understanding or his investigation into how the sides of triangles are related lead him to what we call a theorem or a fact. And Mr. Lamar was about to share the theorem with us. Do you want to share the theorem, what Pythagoras' theorem is, Mr. Lamar?
Sure. The theorem formula is c squared equal a squared plus b squared.
All right. Now, for all right angle triangles, the principles will obey this theorem. So no matter what kind of right angle, no matter how the right angle or how the sides are, once the right angle triangle, it will obey Pythagoras' theorem. And this is a worded version of what the theorem is saying. It says that the square of the length of the hypotenuse is equal to the sum of the square of the length of the opposite and the adjacent side. All right, so that's a theorem. So in other words, that's a maths fact. Now, if we are looking at the theorem in a more condensed form, in the form of an equation, this is what the theorem looks like. The hypotenuse square is equal to opposite square plus the adjacent square. And if we use the labeling of the sides of our triangle in the form of ABC, then given that A is the side of the hypotenuse, B is the side of the opposite, and C is the side of the adjacent. And we loosely use the term opposite and adjacent here. It is loosely used because we really don't refer to which angle that it would be opposite or adjacent to. But because we know that those two sides can be either opposite or adjacent depending on which angle they deal with, we're just saying that call one opposite and call one adjacent. So Pythagoras' theorem would relate the sides in this way. So all right. So the theorem really can be simplified in this equation, which is also considered to be a formula. All right. So for the Pythagoras' theorem, we can consider this to be a formula for Pythagoras' theorem. Now, once you see this formula, you should note the relationship here. So here where we write out it in the form of the hypotenuse. So what it tells you, the hypotenuse we know is the longest side. So it must always be the side that starts the formula, right? So if you're referring to Pythagoras theorem and you're not using it to be the longest side starting the formula, that means you're doing something wrong. So that is the key thing, one of the key things that you are to remember, that the hypotenuse must be the side that starts the formula. Now, there are times when you may rearrange this formula and it might look a little different from what it is now. Depending on how you label your triangle, your adjacent can either be a square, it can be b square, it can be c square. So for a particular question, when you're using the theorem, you don't necessarily go and use the letter in this order all the time. So even though the formula is saying a square equal to b square plus c square, this can only be used in this order if we know that the side of the hypotenuse is actually a, and the side of opposite is b, and the side of adjacent is c. So at all times, the hypotenuse length must be on the left-hand side of the equation for the formula. So that's something that you should bear in mind. All right, so with that said, what we want to do now is to apply this theorem to how we can solve problems. Now, there are a little bit more deeper understanding to Pythagoras theorem. I could show you from a graphical point of view why this is true. So let me just make a quick view of why the theorem really works. All right, so we are saying that for any triangle, which is a right angle triangle, any triangle which is a right angle triangle, I want to, let me make these a little smaller. To get this concept really clear in your mind, one of the things that we often ask the students to do is to construct a right angle triangle. And then now what we do is to ask them from the right angle triangle, construct each of the sides into a square. So if you construct each side of the right angle triangle into a square, so we construct the hypotenuse into a square. Now we can construct the other two sides into a square. And if you remember what a square is, a square has equal sides with 4 right angles in it. All right, so that is the square of, we generally call it the side which is standing tall, the leg of the triangle, and the other one that is sitting horizontal, we call that the base. All right, so we constructed the leg of the triangle into a square. Now we're going to construct the base of the triangle into a square. So it means that our sides must be equal to the side of the triangle that you're using to do the construction. All right, now this is where Pythagoras developed his theorem. What he did was to do something similar to what I have here. And so what he did by experiment, he calculated what the area of this big square formed by the hypotenuse. And we know, let's say we can put some number to it. So let's say that the length of the hypotenuse was, say, 5 units. You want to call it centimeter. And because it is a square, that means all the sides are going to be 5 units. All right. And so let's say that the opposite, or if you may, whichever side you want to call it. This is, say, the adjacent side. Let's say that it is 4 units. That means all the side of this square should be 4 units. And this side, which is the leg, call it the leg or the height of the leg, to be 3 units. Now, by experimentation, what he noticed is that if you should find the area of each of these sides, you would see the relationship that he's talking about. So what he did first was to find the area of the larger square formed by the hypotenuse. So if you're finding area, you're multiplying length times width. So the area of this square would be the length times the length, which is 5 times 5, which is 5 square, will give you 25. And if you do the same thing for the base, the area would be 4 square, and that would give you what?
16.
All right, so area is 4 square, and you would get 16. And if you find the square of the side that the leg forms, you will get 3 square, and you get what?
9, sir.
So the area of this square would be 9. Now, what he noticed here is that if he add the square of these two smaller, if you add the area of these two smaller squares, you notice that 9 plus 16 give you 25. And he continued to do experiments with all different sizes of right angle triangle, changing the hypotenuse, changing the opposite side, and so on. And he realized that that equation always worked out to be true. So the hypotenuse square is always equal to the sum of the other 2 squares formed from the other 2 sides. And so that's how the theorem came up. All right, any question, guys?
So is it possible to run back through that real quick? So because you kind of get lost.
Okay, so I was saying that by constructing these squares from the sides of a right angle triangle, by finding the area of the biggest square, or the biggest square.
Sir, are the squares drawn at random?
Well, the squares are drawn based on the sides of the triangle. So
yes, I realize.
If the length of that side, in this case, the hypotenuse length is 5, so it means that you want all the sides forming that square to be 5. And so we do that for all the sides of the triangle. So what he realized is that if you square the length of the longest side, forming a square and finding the area of it, you get 25 square units. And the same thing for the base. You square this, you get 4 fours, give you 16 square units, and 3 threes for this one, give you 9 square units. So the relationship now is in the form of the equation. You realize that when you add the 16 and the 9, it gives you the same thing as the square of the hypotenuse. And so I
understand it now.
His conclusion is that the square of the hypotenuse is always equal to the sum of the square of the other two sides. So that's the idea behind it. So what he's saying now, suppose you replace these numbers now with general letters, right? So if we replace these numbers, sorry, that's not what I wanted to do. If we replace all of these numbers with letters based on how we label the triangle. So let's say that, this side, which is the hypotenuse, was labeled common letter A. And this side was labeled with common letter B. And this side was labeled with common letter C. Right? Now, what we know that the area of this square would be A squared. And the area of this square would be C squared. And the area of this square would be B squared. So we can say A squared is equal to B squared plus C squared. So that's how the theorem came up. Now, without using the squares on the triangle, so if we should just think of the triangle without the construction of these squares, the formula will hold true, thus the formula will still be true, right? So without constructing the squares, this formula will still hold true. So no matter what size the right angle triangle is, always obeys Pythagoras theorem. So A squared is equal to B squared plus C squared. Now, one of the important things about the theorem is how it will allow us to be able to calculate one of the sides of a triangle if we are given the sides of the other two. So if we know two lengths, so if we know any two sides of a right angle triangle, we can use this formula to calculate the length of the unknown side. And so that's how we use this formula. And that's what we're going to be looking at next. All right. So here we go now. So let's say that we are given a question in a worded form, and it says that and that little symbol means triangle. So in the triangle ABC, it tells you now that the angle B is 90. And by what you know about right angle triangle, once you see a 90-degree angle, that should indicate that you are dealing with a right angle triangle. So if angle B is 90, side A is 4.2, side C is 3.7. Now, one of the things that you will be required to do for this question is to construct the triangle and label the triangle based on the information given. So I'm going to just give you about 2 minutes to draw the triangle, label it in the way that the information is given, and ensure that you represent all the vertices with capital letters and all the sides with common letters, and just fill them in according to what you're given here. And then now I'm going to ask individuals to share how they label their triangle. All right, is that clear? So that's the first thing that you have to be able to do. You have to be able to correctly label the triangle. And then from that, you can do your calculation. All right, guys, 2 minutes. All right, by now I think somebody, person should at least constructed their triangles and put in these labels. All right, so here we have a triangle now. Who wants to walk me through how they label their triangle? Or how to label the triangle? Somebody, anybody? All right, go ahead, Mr. Lamar.
Oh.
All right, Mr. Lamar, tell me how you label your triangle now.
Sir,
Yes.
angle B would be the 90 degrees right angle. Yes, sir.
All right, so here we can assume, just by how the triangle look, we can assume that this is going to be the 90-degree angle.
Yes,
and
sir.
Our angle B would have to go here.
Yes, sir.
All right, what next, Mr. Lamar?
Sir, from that, you know that the side opposite the angle B would be the hypotenuse. So, and you can see that one line is longer than the other line. So the line vertical to the right angle.
Side would be the side common letter B.
So the side common letter B would be the long side, the hypotenuse.
The longest side.
Yes, sir.
Which of these side you refer to as that?
So the side opposite to the right angle.
All right, so that means this would be the side opposite to the right angle.
Yes, sir.
So that would be the side that we label as side common letter B. Now we can label this common letter B. We were not given any value for B, so we can put a question mark. We don't know what B is. All right, continue, Mr. Lamar.
Sir, the common letter A would be vertical to the right angle.
All right, now
Long side.
the question that I'm asking, does it have to be that vertex at the top, or can it be any of
So
them?
not always, but
So
not always, but determined by jargon to describe it.
all right, so what is good in terms of this is that it doesn't matter which of the other two vertices you want to call by the other two letters. So if you want to label up here as A, that is okay. If you want to label down here as A, that is still okay.
So that would be A though.
So it's just a matter of choice now with the other two angles, whichever one you want to label.
Sure, but they can, sure, but they give measurements for each line. So
Yeah, but the angle would not determine the measurement here now.
sir,
The
so
sides would.
so its sides not opposite, so its sides don't have to be adjacent to the angles, don't have to be opposite to the angles.
Well, they didn't tell you exactly. Yeah, the sides going to be opposite to their angles, but they didn't tell you exactly which angle is A and which angle is C. They didn't tell you. So you
Yeah,
can.
but sir, since you can see the length, they gave the length of common A and common C.
So you're saying then, you're just estimating based
Yes.
on the lengths, which of them is shorter and which is longer.
Yes, sir.
All right, good observation. So if you're using the length to be a little bit more realistic, then we would compare the length of these two sides
To this
to
side,
see
yes, sir.
which one of them is the longer side. And clearly, as you were saying, the one that is standing tall would be the longer
Common.
side. So you would label that side as common letter A.
Yes, sir.
So common letter A then would be the vertical side over here.
Yes, sir.
So what you want to do is put in what they give you, and then you can fill in what they don't give you. So A here would be equal to 4.2 centimeters, all right? So that's A. And then if this is a side A, then where will be the angle A?
Sure, the side opposite, the angle opposite to that.
All right, so it means that the A would have to be
Yes,
at
sir.
this end, because you want to ensure that this side is opposite to the angle A. All right, continue.
So then the vacant side that doesn't have a would be 3.7, which is C, and angle C would be opposite to that.
So it is kind of go without saying now that this would have to be the angle C,
And that would have to be
and this
line
would
C.
have to be the side C. All right, because those are the other two elements that we have remaining. So we would have 3.7 centimeter for this side. And this angle now, we don't know what this angle is, and we don't know what that angle. So for Pythagoras' theorem, when you're using the theorem, you don't really need to know the other angles. Only one angle that you really want to ensure that you have is a 90 degrees. So once you have a triangle and you know that one angle is a right angle triangle, which is a 90 degrees angle, all you need to do next is to now use the theorem based on how the formula presents itself. Now, remember I said to you that in writing the formula, the formula don't necessarily going to start off with A. So based on the triangle that you have, you start off the formula with the side of the hypotenuse. So in this case, if you were to write the Pythagoras theorem formula, what would you write as a formula?
So b squared
So the formula would be b squared
equal a squared plus c squared.
a squared plus c squared. So that is important that you write the formula based on the triangle that you're working with. Is that clear to everyone? So that is one of the key steps. Once you write the formula based on the hypotenuse, starting with the side of the hypotenuse, then you're well on your way. The next step now is to plug in the values that you know
Yes, sir.
from the question. So what are the values that we know in terms of the sides?
So 4.2
For which side?
for the opposite side.
All right. So we know that A, the side A is 4.2.
Yes, sir.
So in the formula where we have A squared,
We would have 17.64.
we are going to replace the A with the 4.2. So that would be A. But remember now, A squared would give you 4.2 squared.
Yes, sir. Just 17
All
plus c
right.
squared.
So before we jump to the answer, let us just finish writing it out in this form. So for the C now, we would have C being 3.7.
Squared.
This is C squared, so this has to be 3.7 squared. Now, once you have written it out in this form, then now you can do your calculation by working out what the square of these numbers are. You can use a calculator. So
Yes, sir.
you're trying to find B, you don't know what B is.
B squared is now equal to
So you use your calculator, calculate 4.2 square, you get what?
17.64.
17.64. So remember, guys, you have to work out these square terms. 17.64, you said?
Yes, sir.
All right, so it's 17.64 plus
30.